second. Yeah, I have to log into my separate account. Okay, here we go. All right. So, with that being said, I don't think I'll need a timer because I'm pretty sure I'm well under 5 minutes, but I do have notes to go over. All right. I suggest that, well, first let me start off. Hi, my name's Omni. Right now, I'm going to be arguing for a globe Earth model in this debate, and with that, into my opening statement. For this debate, I suggest the purpose of this debate is to determine which model, the flat or the globe Earth, is the more correct model, and if it should be treated as such. When it comes to determining correctness, I'll appeal to a few metrics and I ask everyone else to do the same, unless you have metrics they believe should be used instead. The first I will argue for is consistency, which explanation is consistent in its explanations and does not falter or change depending on the scenario. Number two, the amount answered, which explanation is able to provide a sufficient explanation for a certain phenomena. And number three, the validity and ability to be tested, which explanation not only can be measured and tested, but is the explanation valid in offering why it is such. The system, I hope, will be used to determine correctness and how us as people should view the Earth's model. It provides a way for us to answer, such as, God's created it this way, to be more valid and more correct than someone who just simply appeals to some random fallacy that has no two means together. Next, a few key concepts I want to try to establish, or at least hope to establish amongst this debate, and I ask that Jim, if we take a small amount of time after our opening statements to each explain these three concepts and give a idea to comprehend each concept so we can then have a mutual understanding of our models and how to assess them. The first concept I want us to understand and put out will be the surface area of the Earth, and just to let you know, I will do this as well. Number two will be the general idea of physics, specifically an explanation as to how our acceleration toward Earth's surface is explained, or how we describe it. And number three, the model of the Earth and the model of the solar system it resides in. With these explanations, I can offer a reason as to why I want such. The first will be, the Earth's size is a paramount in understanding how our perception relates to the model of the Earth, as models offering a gargantuan size can provide explanations as to why perceived illusions are nothing more than exactly that, illusions. Number two, physics is a word to indicate how a world operates. What explanations can we give off as to why, when I pull a rope, it comes toward me? The specific case I mentioned was that of why things seem to be attracted toward the floor. And number three, the explanation is, once we have the size and the physics of how the Earth operates, we then need to see if our models fit inside our given explanations. Now, that doesn't mean you have to have an answer, but the more you can answer with consistency, the more can establish to be correct using my metrics. I believe the globe Earth model is the correct model when it comes to the Earth. Physics currently understood by man offers a consistent, testable explanation to almost every observable phenomena, and I believe the flat Earth model does not. That is what I attempt to prove in this debate. All right, that's my opening.
Thanks, Omni. Hey, my name's Jim. I go by Waterworld. You can call me Jim if you want to. I think just to respond quickly to Omni is we don't live on a model. There's no model. In fact, I have a model of Santa Claus. Is Santa Claus real? I also have this model of the Easter Bunny. Does that make the Easter Bunny real? We do not live on a model, my friends. We experience, we observe, and we see the world we live in. So, we do not live on a model. There is no proof that a model is the real thing. So if my good friend wants to argue a model, then let him. That will be my response in most cases, that if he thinks we live on a model, then Santa Claus is the model, must be correct. So anyway, hey, Ruhef, my good friend from Australia, how you doing? Here's the situation we have. I take the path that we live on a stationary topographical plane. Stationary has been proved over and over, starting with Michelson Morley, all the way up to Dayton Miller and a guy by the name of Juice, not Juice, but Joos. So there's never, ever been motion of the Earth proven around the sun. Not one time, ever. So why do we think it does? Just because Einstein said it did? I'm sorry. So some simple things that we observe, that we see, that we experience. We think it's a ball, though it measures flat. We think the earth spins, though we don't feel it. We think the earth moves around the sun, though we can't measure it. We think water curves around the ball, though we can't see it. We think light curves in the medium of air, though we can't prove it. We think gravity exists, though we can't explain it. We think there is a universe, though we can't verify 95% of it through dark matter. If you look at general relativity, Einstein's general relativity, for it to work, we have to have 95% of something out there in the universe that we cannot explain. We just take 95% of the universe and put it out there for general relativity to work. That's exactly what we do. And then we have people that tell us that we are off by 10 to the 120th when it comes to dark matter, when it comes to the universe. 10 to the 120th is 120 zeros behind the 10. Let that sink in for a second. That is the model, M-O-D-E-L, that we want to look at today. It makes no sense whatsoever. It is a fairy tale. It's just really quite unbelievable. So I don't have a whole lot of time. Maybe next Saturday we can take 10 minutes or whatever. Here is George Wald, Origin of Life, Scientific American, August 1954. George Wald won the Nobel Prize. When it comes to the origin of life, we have only two possibilities as to how life arose. One is the spontaneous generation arising evolution. The other is the supernatural creative act of God. There is no third possibility. Spontaneous generation was scientifically disproved 100 years ago by Louis Pasteur, Spallanzani, Redi, and others. This leads us scientifically to only one other possible conclusion, that life arose as a spontaneous creative act of God. I will not accept that philosophically because I do not want to believe in God. Therefore, I choose to believe in that which I know is scientifically impossible, spontaneous generation arising to evolution. Johannes Kepler said something very similar. He said, and I have the quote, but I'm going to run out of time here.
You can take more time, by the way, just to let you know.
Oh, well, thank you. You're very kind, sir.
Yeah.
Is that okay with the moderator?
Yeah.
Thank you. That was very nice of you, Omni.
Yeah,
Thank
for sure.
2 minutes and 30
That-
seconds. So you
That's
can
very
take
nice of you.
Oh, yeah, no. Please go as long as, like, 10 minutes. Please take it all.
Oh, it's what I really appreciate that. Thank
Yeah.
you. You're very kind. John Calvin, who I think many will think helped with the Protestant Reformation with Luther. Luther started in 1517 with his 95 Theses. John Calvin said this: "We will see some who are so deranged, not only in religion, but who in all things reveal their monstrous nature, that they will say that the sun does not move, and that it is the earth which shifts and turns. When we see such minds, we must indeed confess that the devil possessed them, and that God sets them before us as mirrors in order to keep us in his fear." Mr. Hubble, Edwin Hubble, which if you followed Austin Whitsick for a while, you will know that Austin loves this quote. Edwin Hubble, Hubble telescope, 1929 redshift, ever expanding universe, redshift, blue shift, if you're familiar with redshift, blue shift, and Edwin Hubble. He didn't come up with the idea, but he fully explained it in 1929. Edwin Hubble said this: "Such a condition would imply that if we think that we're the center of the universe, such a condition would imply that we occupy a unique position in the universe. In a sense, to the ancient conception of central Earth, this hypothesis cannot be disproved." He cannot disprove the fact that we aren't the center of the universe. "But it is unwelcome and would only be accepted as a last resort in order to save the phenomena, Earth around the sun." Therefore, we disregard this possibility. The unwelcome position of a favored location must be avoided at all costs. Such a favored position is intolerable. Edwin Hubble. We cannot be the center of the universe, friends. We have to be, and we've all been taught since age 5, me included, we all have to be, here's a model if you want a model. We have to be on something like this as a model. We have to be spinning at 1,037 miles per hour at the equator, less as you go up and down. We have to be going throughout, going around the motion of the Earth at 66,600 miles per hour, 30 kilometers per second. We have to be going, the solar system has to be going throughout the Milky Way galaxy at 450,000 miles per hour. We have to be going throughout, the solar system has to be going throughout an ever-expanding universe at 1.3 million miles per hour. Over the course of 200 years, that would be almost 2.2 trillion miles. And the sky resets every single year. Nothing has changed above us. Think about that. Nothing has changed above us. We have a sidereal, S-I-D-E-R-E-A-L, rotation of the sky above us, which translates motion down to the Earth. Basically the same thing as waving your hand above a bathtub and having the water move without you touching it, but nothing down below moving. That is the world we live in, friends. We don't live in this Big Bang 14.5 billion years ago. We are not the ancestors of some amoeba coming out of the water. We are not ancestors of some monkey. We are special in the universe. God put us here. Whether you're biblical or not, God put us here. It's quite evident in the Bible. We won't get into biblical cosmology because that's not what Omni and I agreed upon. So anyway, I just want you to know I appreciate being here, Omni. I appreciate you giving me a little extra time, and we're ready to go. Thank you. Thank you very much for having me.
Awesome. No, that was great. That was a good opening.
Thank you.
If you do not mind, I just want to clear up a few things.
Please.
The first thing I want to ask is, you said that when I said like the Earth's model versus your model, you said we don't live on a model, and I agree. I don't think we live on a model. But can I ask like what your interpretation of model means?
Well, I tell you, my interpretation of a model may be some lady or guy walking down, walking down in front of other people, and showing off their body or showing off whatever they're wearing. So that may be my interpretation of a model, but we don't live on a model. I'm always impressed that people, not really impressed. I shouldn't say that. I'm impressed, not impressed that people talk about a model as if, Omni, I want you to know, if you keep bringing it up, I'm going to give you Santa.
I mean,
so if you want to talk about a model, I can model anything. People are modeling a concave Earth. You could probably model a rectangular Earth. You could probably put it in the math and make it work. And I guess one of my main questions, can I ask you a question or two?
Yeah.
Do you mind?
Yeah.
If you, obviously if I talk too much, just tell me to be quiet.
Oh, you're fine.
Here's a question, my friend. Does math prove your ball?
I would say it leans highly likely toward it.
Okay, so math proves your ball. Do you know what the Lorentz transform equation is?
Not off the top of my head.
Okay, the Lorentz transform equation basically came about because Einstein said in 1922 at Kyoto, K-Y-O-T-A, in Japan, he said that he came up with special relativity in 1905 to counter Michelson-Morley of 1887. He said that it is in his writing, and the thing that gets me is that the Lorentz transform equation is one of the most used equations ever. I'm surprised you don't know about it, but it's okay. It's fine. But the Lorentz transform is 1 minus square root of 1 to the square root, forgive me, 1 to the square root of 1 minus VC divided by C squared. So velocity squared speed of light squared. And so it is the most used equation ever, and this is the reason it's used. It's because we have something called coordinate systems. We have it in physics. We have it we have it in something called tensors. We have coordinate systems. When you have a coordinate system, you have the Earth going around the sun or the sun going around the Earth. The Lorentz transform, whenever the ball starts to get in jeopardy, they will use or invoke the Lorentz transform to go back to the coordinate system that they want, which says the Earth is revolving around the sun. It's that simple. And Omni, it's done in the math using science, or done in the science using math. It is all hogwash. You do not prove anything by math. I'm sorry, and the Lorentz transform proves that. All yours.
I guess I didn't necessarily understand. I would have to look into what the exact Lorentz transform proves, but I'm not willing to comment on that. But I'd like to go back in just because I simply need to look into it. Right? It could be an extremely valid mathematical equation. I don't know about it. That's the problem. But what I do know about is back to the original question was the idea of like what a model is. And a model is not something that is claimed to be this. Like when I say I'm living on a model, I'm not saying that. A model is used to represent something that can be found in reality. Usually in reality, there could be instances of saying, oh, here's a model for Santa Claus, like you said, right? But when we talk about models of the Earth, it is a representation of what we believe to be physical. And so this model, we're going to assign properties to it that's going to be things such as that which we ascribe to physics. And these physics is the stuff that I brought up my first 3 original questions I wanted you to clarify. It seems if you don't have an answer, that's perfectly understandable. But I would then say when you're going towards saying what is more correct or how we should operate or what to believe, when you compare the two and you talk about everything that has a relating factor, everything that can be related to something else, when I drop an apple from my hand, I watch it fall to the ground, and I can explain that and you can't, and I can explain every other scenario that seems to be in our perceivable eyes, we can have a discussion about which one should be used. And I would suggest the one that gives us an answer that is henceforth used in every single instance and correct in every single instance and applied on at least a perceivable level from just our human eye. I would say we should use that, and that's what we do. We use Newton's equation of gravity. It's not the most correct because when you talk about extremely minute things that we can't perceive with our eyes, we can't figure it out. But it relates to everything that has to do with what's in our eyes, our perceivable. And then we get into more extremely dynamic, more abstract concepts of gravity when you talk about extremely small objects. But that's a subject for another day. The idea is we can conceivably understand every single instance of perceivable physical reality and how it operates, and we can give an explanation aside from a few instances such as like singularities. But aside from the explanation of the model, that hopefully you'll be able to, if you disagree, you can tell me. If you agree, you can tell me. I also want to go over some of those quotes you gave. The first one you gave was George Wald, and your explanation as to why it was kind of a proof as to, not necessarily proof, but just reason to believe against my position. It seems as if the only thing you said was that he was a Nobel Prize winner. And as much as I think that's an accomplishment in and of itself, after looking into George Wald, it seems as if he was very established in terms of science when it came to like eye examination and retina display. He was very, very advanced when it came to understanding how our eyes work and how they perceive light. But that doesn't mean you're necessarily knowing of cosmology or astronomy or being able to comment on the shape of the Earth or knowing how to explain the shape of the Earth. Obama was a Nobel Prize winner, but I wouldn't trust him when it came to a doctor's opinion. Just because you have an award for something doesn't mean you should be listened to. The next would be John Calvin. And while John Calvin, in his own right, is someone that could be praised, I would say that someone living in the 1500s isn't someone that I would trust when it comes to the forms of models, not necessarily because he was stupid, but because he might not have been given the same access to information that we have. He might have come to the same conclusion as we have, given more time, given more explanations. If he was given, say, Einstein's theory of relativity, maybe he would agree with it. We don't know because it was so long ago, and I don't hold that against him, but I will not hold his perception of our Earth as credence of fact. The next would be Edwin Hubble, and this was one that I was curious about because I researched this because I was aware of its existence and why people used it, and I was curious because I was thinking Hubble is a very smart person, and it seems as if he is very adamant that we cannot have this answer, and that's scary. I don't like scary things. Well, when I looked into it, I'm not sure if you're aware of its existence and how the actual context is in that area, but it's chopped up. The first sentence, the first 2 sentences that you read in the explanation that I went into, It was one sentence followed by so such a condition would imply that we occupy a unique position in the universe. That sentence, which is then followed by, at least in the quote that I read, yours included another sentence, but the unwelcome supposition of a favored location must be avoided at all costs. Those two you said in dynamic, one in between, but essentially in the actual text, there is not only an entire paragraph, but multiple sentences between those paragraphs. Next, it came for the other part you said. Such a favored position of course is intolerable. Moreover, it represents a discrepancy with the theory because the theory postulates homogeneity. That was an entire page away. Actually, I think that was more than a page. It was multiple sections away. When you look into like the context related to this, and in the context it explains, he was criticizing a different perception, and it was a thought experiment when it came to, oh, are we aware that this could be an answer? Yeah, it could, but like we want to avoid that because right now it's completely explained in the context, and it's not this hardline stance of we have to avoid a Earth being the center of the universe model. No, it was more so just in response to a different paper when it talked about a different theory. Right, so as much as I don't think that you intentionally misrepresented it, I do want to say that that in context was wrong, right? Next, you would say that the nothing changed above us. I would say that actually we disproved that. Galileo, in his famous example of how he proved that we are not the center of the universe, he saw 4 different shapes of Venus. How is that explained if we can say nothing changes above us? The fact is, a lot of things change above us. Some things stay in line to what we usually see, but they shift ever so slightly, and other things change completely. We can lose stars. We can lose areas that we don't really see. After through Hubble, we have the telescope. We can see different things in the areas that we can say, wow, those have changed. So it's not this stationary object, and while I can't give you an explanation as to the Lorentz transformation equation because I simply don't know enough about it, I think that this is all fair to say that everything I've presented, I still have explanations for. And right now, I've yet to hear a single explanation from you.
Do you think we've had in the past, we've had Newton's gravity, we've had Einstein's gravity. You know the difference between them?
Yes. Einstein's more on the molecular level, like you're going to have very small objects. Newton was more just the perceived reality, which is understandable because he didn't have the technology to know smaller things.
So is Newton's gravity observed today, or does science go with Einstein's gravity?
It's a I would say both, because when you talk about how Newton's is used today, everything that we can perceive without the use of tools, it's Newton's laws. It's completely one-to-one with Newton's laws of gravity. You can measure every single thing that we can see with our eyes with Newton's laws of gravity. It is correct 100% of the time. However, when you go into the things that are not our perceived eyes, that we have to use instruments to see, that is when it starts to fall apart. And that is when you have to take Einstein's theory of gravity and start to address these things.
I think the Royal Society of November 6, 1919 would disagree with you firmly in what you just said. You have the 2 expeditions of May 29th, 1919 that went out to look at the eclipse of the sun, and they had a star behind it. There was 2 expeditions. One was Eddington, and basically what they did, they took 36 shots, 36 photographs, and they came to the Royal Society in November 6, 1919. And they talked about it. There are notes about it. And at the end, they took 2 photographs that were basically inconclusive. I have quotes, which I may not bore you with, that tell you how bad it was. And they took 2 photographs out of 36, and said they saw the bending and warping of space-time. That is what Einstein's gravity is. It is the bending and warping of space-time. And they took that and they said, well, we got to, they basically went into the whole thing saying, we got to get rid of Newton. Newton's falling apart. Mass attracts mass is falling apart. So they took 2 out of 36 photos and said, Einstein's our boy. They told the USA and the UK press on November 6, 1919, that Einstein is in and Newton is out. And when Einstein woke up November 7th, 1919, he was savior to the ball. So my question for you, my good friend, is space-time, is general relativity Einstein's general relativity, which is basically the bending and warping of space-time, is it physical or is it theoretical?
I would two things. First, to answer your question, I would say it's a theoretical concept that applies to the physical world, and then second, I would say nothing you said disagreed with what I previously said. I said without the use of tools, Newton is still 100% correct on everything. It's when you start to put tools into the fact, when you're able to zoom out extremely far, you're able to actually get these things that may or may not disagree with what Newton said, right? So they can still be both correct on a certain level, but when you get to certain minutes, you'll run into problems.
Can you prove gravity for me? Other than the effect of 9.81 meters per second squared, that's agreed upon average of how things fall to the ground. Can you prove gravity to me? Can you show me? Is gravity a wave, a waveform? Is it a particle? What is gravity? Is gravity quantum mechanics? Is gravity Newton? Is gravity Einstein? What exactly is gravity? Can you tell me?
Well, gravity is, as we conceive of it, is the gravitational force between two objects. So when I drop, when you say without using the speed of how something falls toward the Earth like this, without using that, that's kind of defeating the whole purpose of what gravity is. Gravity is an explanation. It is not necessarily it is not sorry, it's a description, not necessarily an explanation. Gravity is simply just to refer to this thing. When I drop this pencil and it lands on my desk, that is gravity. Gravity is what is doing that. And when we talk about how we get that, we say, we can measure this. We can get what this is, and then we can now expand upon it. And when we expand upon it, it seems to correlate with everything that we can conceivably see. At least in the, obviously Newton's is going to conceive slightly different if you get to molecular, but that's fine. In the case of a pen dropping to the center of the Earth, or toward the floor, we have our gravity. That is gravity. We don't necessarily know why, but we know that it's a thing.
Who came up with gravity? Mass attracts mass.
That would be, well, I mean, to my knowledge, Sir Isaac Newton.
Did Newton ever write about the apple falling on his head and falling to the ground in 1666? Did he ever write about that?
I don't know. I do know that he wrote about his the equation of gravity, which was in my answer to the original three questions I asked, so we could understand each other's models a little bit more. So he did.
I don't live on a model. I want you to know that.
You're right. You live on the Earth.
I experience and observe a stationary topographical plane. So Newton never wrote about the apple falling on top of his head.
Never said that.
I didn't strawman you. I didn't say that.
Oh, you were just. Oh, I got you.
I was just making a factual comment.
Mm-hmm.
Newton never talked about the apple in all of his writings. He actually wrote over 1 million words on alchemy. Alchemy has one of its bases, lead be able to turn into gold. That's alchemy. He wrote over 1 million words on alchemy. Do you know who the father of alchemy is?
I do not. Is it Sir Isaac Newton?
The father of alchemy is Hermes Trismegistus, some sage a long time ago, who was a sun pagan worshiper. And Sir Isaac Newton wrote over 1 million words concerning alchemy. He even took the emerald tablet that supposedly Hermes Trismegistus wrote, and he translated it. He translated Hermes Trismegistus' emerald tablet. Towards the end of his life, Newton said that he wanted nothing to do with alchemy, even though he wrote over 1 million words on it, because it made him look bad. Also, John Maynard Keynes, Keynesian economics, big, supply, not supply side, but let's just, spend our way out of recessions and depressions. In 1936, he bought Newton's papers, and he went to the Royal Society in 1936. He's not on our side. He's definitely on your side. Big liberal socialist economist. And he went to the Royal Society, and he said at the Royal Society that Newton was one of the last magicians and that he should not be taken seriously. So Newton, towards the end of his life, knew that he was basically something's going on. He wanted nothing to do with alchemy because he didn't want to have his reputation discredited, because alchemy, as far as one of its foundations, is that lead can be turned into gold. And so Newton, this whole thing about Newton, We can talk about electrostatics if we have time. We can talk about all those things, why things go to the ground at 9.81 meters per second squared, agreed upon average. But if you're telling me that the bending and warping of space-time is theoretical, then why do you believe in it? If you can't see gravity, then why can't you believe in it? You said Calvin was somebody back in the 1500s. How can we take him seriously? I'm not sure if that was your exact words or not. But so if you can't take Calvin seriously, how can you take Copernicus and Copernican theory seriously? He was born in 1473, supposedly died in May of 1543. He gave us On the Revolution of the Heavenly Spheres, which is basically what Copernican theory is. He started the whole deal. He didn't give us six planets going around the sun. He gave us something called orbs, which was just right inside of a little ball. They were called orbs. And the fun thing is about Copernicus is that he on the revolution of the heavenly spheres, the big thing that started out this ball, he even used and talked about Hermes Trismegistus on the revolution of the heavenly spheres, and Hermes Trismegistus talked about how great the sun was. My friend, heliocentrism is based solely on sun pagan worship because we have never ever experienced through empirical or physical evidence the earth going around the sun. We have never ever experienced. This is why I reject the model, because we don't live on a model. We live out here in the real world. We experience and we observe a stationary topographical plane. And in a second, we'll get to Michelson-Morley, and we'll get to the interferometer experiment starting in 1881, and we'll go through 1930, and we'll go through all those experiments. And I will be happy to do that. If you haven't heard have you heard of Michelson-Morley?
I'm not.
Okay, so
if you don't mind, would I be able to respond to the other stuff first?
No, I'm sorry I rambled.
Oh no, you're fine. No, I appreciate it. I do truly like listening to everything you're saying. So to address a few things that you put, the first that I want to start with is the one that you keep repeating multiple times, the stationary topographical plane, and like how this is what we perceive, therefore this is what we should think it's such. And that's where, in my initial opening statement, I brought up the point that something scale can really influence how it's perceived, right? When we talk about my model, and I know you say we don't live on a model, I don't think so as well, but I do believe that a model can be a descriptor of what we do live on. And with this thing that we live on, it is seen to be 510 million square kilometers, and something of that sheer size and scope. When you look outside, it's going to seem flat, and it's going to be flat, because when you put into perspective the angle at which my model has to represent the Earth going to be able to achieve a spheroid, it is going to be extremely close to 180 degrees, and 180 degrees is exactly what we would see as flat. So that is why when you say you observe a stationary topographical plane, that's because I do as well. However, after viewing such, I then go out and say, there are other questions I have to ask. And I'm not even questioning if we're a flat Earth or not. I drop an apple, I drop my pen, and I say, what is this? Okay, here's an explanation, gravity. Okay, well, why is something going toward the floor? Why is this? Okay, well, let's think about that. Why is that? After all these thoughts of explanations of why it is that something goes toward the floor, we arrive to a singular instance conclusion that works in every example and also is applied to almost everything else conceivable. And that is that mass attracts mass. If the Earth is so big that it appears to be a topographical stationary plane, then that solves the perception issue. And if its mass is so massive that we have an attraction toward it just by simply being on it, then we have an answer for gravity. And then when we start to peer outside, or peer upwards in this instance, after we have that explanation, we see, oh, look, why has Venus have 4 different shapes? Why is Saturn's 4 moons? What are these questions? Why are these the same? They're answered with gravity, and we have an explanation. And I'm not supposing to you that I can prove it to you with your eyes. But what I am saying is that when we have an equation that works for 99.9% of instances, and then after we show this equation and then we say, we understand that it's not perfect, but it's something to go off of, and you supposit that it is not something to go off of, what is the other idea? This equation works with everything. There is not even an equation you're offering to almost everything. There's no equation that you're even offering in replacing. It's an answer that works in every single scenario that we could possibly perceive with our own eyes. However, after that perception, you're saying it's wrong because it seems as if all I've been told right now are quotes, and that's kind of it. Which I think quotes are valuable, but what I'm asking for now is why it is that I should not believe what I'm saying. Is there anything you could falsify when I drop something, any equation that I put forth when it comes to what we see on Earth, things that we perceive, not things that are observed with magnifying glasses, not things that are observed outside with telescopes that can appear hundreds of thousands of millions of miles away. I'm asking you something that I can perceive 10 feet away from me. Can you offer an explanation as to why it does this? That isn't just saying I'm wrong.
You've been. Would you agree with me that we've been giving one explanation since we were both? I'm a lot older than you are, but we've been giving one explanation since our earliest memories of why things fall to the ground, and it's always been gravity. Have we ever been given any other alternative besides that?
I mean, I was raised extremely Christian, however, or sorry, Catholic. But I was never given an explanation. Just more so said that it is there, but I was never told it was gravity. I was actually told that gravity didn't get created. But beside the point, yes, only one explanation has been given to me.
Sure. And I have this little response, but I just wanted to show you something else here. So you've been given one choice about this too. You weren't ever told about a stationary topographical plane or a flat Earth or concave or any of those things. You were always taught this from your earliest memories.
Here.
Is that correct?
Yes.
Okay. So can I say that you and I both, and everybody probably listening, was propagandized, brainwashed, told that we live on a spinning, watery, curvy, bendy ball in the vacuum of outer space. And we had TV shows and movies that basically backed that up, including Universal Studios and their little ball with Universal coming across of it when we go see Maverick with Tom Cruise last summer. Would you agree that education and entertainment has basically confirmed our propaganda and brainwashing starting at age 5 or so? Would you agree with that?
I would not, no.
You wouldn't agree with that or disagree with that?
I would disagree with what you just said.
So what part of what I just said would you disagree with?
That the entertainment is the stuff that has been propagandizing our education.
Education does it, and then entertainment does it. So would you disagree that would you agree that education teaches a globe or a ball or oscillating spheroid, whatever you want to call it?
Yeah, I believe it does.
Would you say that the entertainment industry also tells us we live on a globe or a planet or an oscillating spheroid?
I don't think so. I think it more so presents it as such, and it's not really telling us. It's more so that's what they believe, and that's what's shown.
Okay, so they're confirming what we were taught in education.
I think it's more so using what we're taught in education.
Okay, very good. I like that. I like honesty. I tell you what. I'm going to, if you give me just a couple minutes here, you know about the Cavendish experiment?
No.
Okay. Cavendish, Ruhef, my good friend down here from Australia, could probably tell you more about Cavendish than I could. But Cavendish is a famous experiment where they put 2 balls in a cage or a box, and they supposedly went towards each other, and that confirmed mass attracts mass. Cavendish, Cavendish, and it's what the globe earthers like to say proved gravity. And it's very famous. Cavendish, very. It's like the Lorentz transform. It's very famous. Cavendish is very famous. And so I'm going to give me just a little second. If you want to chime in or cut me off because I'm talking too much, please do. I appreciate you being here. we can get away from gravity simply because we can look at electrostatics. Everything is electrostatics in the world. Everything. You cannot get away from it. The Faraday cage cannot get away from the electrostatics. Everything is electrostatics. Rubber, glass, water, everything is my hat is electrostatics. So electrostatics, everything is intrinsically electrostatic. You can't block it, nor can you eliminate it. There, at some point, some people might call it the ether. Electromagnetic fluctuations exist within it, something called electrostatic induction. The rebuttal from the globe earthers is that electrostatics can also repel. It cannot. Incoherent magnetism, as the two masses or objects in Cavendish are both incoherent. Incoherent magnetism, void of polarization, is only attractive. And in fact, the strength or pull of the magnitude of the force is inversely proportional to the mass. Therefore, you will get a very weak effect due to incoherent dielectrical acceleration or incoherent magnetism, because incoherent magnetism is only attractive. There's no polarization, therefore, there's no repulsion. So Cavendish, which supposedly told us that mass attracts mass, can easily be rebutted, rebuked, debunked through electrostatics. Now, I'm going to give you your equation: 9.81 meters per second squared, agreed upon average for why things fall to the ground. Within, do you know what the variables are inside of 9.81 meters per second squared? What do they use? What do they use to get there?
There's going to be an insane amount of variables. I believe that right now the Chinese came up with a variable that is really advanced. I think it was 2018 or something.
The two things they use inside of gravity, 9.81 meters per second squared, is the radius of the Earth and the mass of the Earth. That's what the two things they use. Now, let me ask you this, my friend. Who measured the radius of the Earth? First of all, do you know what the radius of the Earth is?
It's like what, 21 something kilometers?
It's the radius of the place that you think you live on is 3,959 miles. Kilometers about 6,200. So it's 3,959 miles. The radius times 2 diameter times pi, you get to the circumference of 24,901 miles. That is the world that you think you live on. And it's really important, because if you throw out the radius, then nothing works. Nothing works. Now, whoever measured the radius of the Earth, considering they've only gone down 7.8 miles in Russia, and it took them 20 years to do it, and they found out it was warmer than they thought it'd be at 7.8 miles. Whoever measured the radius of the Earth?
I imagine it was more so extrapolated from getting the circumference of the Earth.
So if they were wrong about 7.8 miles down as far as the temperature of it, how could they ever know what the core of the Earth is, and how would they ever know that?
It's more so about, like, if we have an explanation as to why things do certain things, then we can say, hey, you're going to need a shit ton of heat in the center of the Earth. How are they going to get that? Oh, if we have stone might have the consistency of iron beneath it. The consistency of iron might melt if it gets hot enough. It might be hot because of all the pressure against it with the density. Therefore, we're going to have molten magma. All this stuff, it's all explained. And to get the radius, it's not that hard, especially when we know that we can travel across the surface of the Earth, because you can get the radius with the surface. Circumference...
Who's traveled across the ball or the oscillating spheroid? Who's done that?
I imagine that a lot of people, when they've traveled the countries, remember Christopher Columbus, all them travelers, probably got a pretty good map.
So, do you live on a map?
I don't know.
Okay, you don't live on a map or a model, but you believe because of a map or a model, you live on a spinning, watery, curvy, bendy ball.
Here, let me show you something about models, right?
Please do.
It'll take 5 seconds.
Please, as somebody once said in a debate, please educate me, my friend.
Hey, guys.
Yeah.
While you're drawing that and doing it, I just want to do a quick time check. We've been going for about 45 minutes. Omni, I know you had some...
Yeah, I got to go in 15 minutes.
Okay, so we have some questions for Jim. Jim, I don't know if you can stay longer. Like, a lot of the questions are for you. So if you want to stay longer and do questions with the audience, that might be great.
Yeah, I can stay as long.
I'll be honest.
I can stay as long as you need, sir.
Okay, so why don't we just let you guys keep doing back and forth? Because I think there are like 1 or 2 questions for Omni, so we can go through those in the last 5 minutes maybe, and I won't interrupt your back and forth anymore because you guys are keeping great time. You're going about almost like to the minute, 3 minutes each anyway.
Perfect.
And then we'll just go through all these questions with the audience. Jim will bring people up to even talk to you directly.
All right. So what I was saying was that this picture I drew of my hand not just a few moments ago, and this is a model of my hand. Does this model have a certain degree of certainty of how equivalent it is to my hand? Does it represent something in physical reality?
I love that. I really enjoyed talking with you, Omni.
I
Thank you.
enjoy talking with you. I watched your YouTube stuff, and I actually was really enjoying it.
You took your hand and drew it. I'm glad you could do that.
Yeah.
You have never seen a ball or oscillating spheroid or a blade spheroid or a planet or a globe, whatever you guys want to call it today, with a radius of 3,959 miles, with a circumference of 24,901 miles. But you drew your hand really well. I have a question for you, Omni.
Wait, let me clarify, because I think you misunderstood my point of doing that. So
It's
my
okay.
point,
It's okay.
yeah, my point of doing that was to show you, and now I'm just going to ask you some questions that will hopefully lead us to the solution I was getting toward.
Okay.
Does this thing that I drew on this paper represent something in real life?
It represented your hand that you just drew in front of you.
Would you say it's an accurate shape of my hand? Because I drew it hopefully one.
That is okay. I'm going to be kind. That is
Yes.
a complete non sequitur.
Wait, can you answer it though?
It's a complete non sequitur. Do you know what a non sequitur is?
I do, but right now I'm asking, and you can explain why I say.
Hey, you drew your hand, Omni. Good job.
And now I'm asking you if
now prove to me your oscillating spheroid or your oblate spheroid
I'm
or
attempting
your planet, your globe, your sphere, and show me your gravity.
I'm attempting to right now. So right now, what I'm attempting to do is show you how a model can be used to represent something in physical reality. So what I drew on this paper, would you say that it is an accurate representation of the shape of my hand?
For your hand, it's just great because you just drew around your hand.
Exactly.
That is entirely different than mapping or modeling a globe of 24,901 mile circumference. Okay. Would you agree?
Well, right now, let me just finish my questions, right? So if that is an accurate representation of my hand, we have now shown that you can map physical things of reality onto paper, and it can be accurate. So let me ask you another question. Say somebody was to have a say they were able to, you can measure a mile. We can both measure a mile, right?
Yeah, we can measure a mile on a stationary topographical plane.
So then say you had a reference and you have your thumb, right? I put my thumb, I make a line, and I say, this shape right here, these two indices, that is the shape of my thumb, and every time I put that thumb, I have walked a mile. So I then take that exact shape and I walk 3 miles, and then I put X on my position and 3 lengths of my thumb. Is that an accurate representation of me walking 3 miles if I explain to you the methods I used?
The non sequitur. I have a comeback for you. Ready?
There's no comeback.
It's a non sequitur, and it doesn't prove your ball.
You can tell me why it is a non sequitur after you answer, because you can say it's bad faith. Is it a representation of me walking 3 miles?
Okay. It's bad faith. Can I ask you a question?
Well, are you telling me it's bad faith, or are you saying?
Yes, because you're not being honest. Because drawing your hand and walking 3 miles can be done on a stationary topographical plane, and it can be done. You can walk 3 miles on a stationary topographical plane.
You're failing to understand the purpose. The purpose of me putting that.
I understand just fine.
Okay, then let me try to restate it. So maybe you can just. We don't need any explanation of a non sequitur. We do need to hear if there is an answer. If I write an X, and I'll do it right now. If I write an X to indicate my position, and then I walk a mile, and then I said the measurement was my thumb, and I put a line, and then I walk another mile. I go from that line, put my thumb, another, and another. Is this, what I'm showing you, even though it is on a piece of paper and is most certainly not 3 miles in length, is this an accurate representation, using the measurements that I used, of me walking 3 miles from this X? Yes or no?
No.
If you do not have an answer to that,
are you trying to prove your ball, or are you just trying to win a point?
If you don't have an answer to that, then I'm afraid to say that I don't know if I can continue to prove this to you.
So, do me a big favor before you have to go. If we live on a ball of 3,959 miles, circumference of 24,901 miles, show me 8 inches per mile squared. Because on a ball of 3,959 mile radius, you should have a hidden curve of 8 inches per mile squared. So, can you show me anywhere that I can go on terrestrially, which means on the Earth, that I can see 8 inches per mile squared on a ball of 3,959 mile radius? Can you show me anywhere I can go and see it myself?
If you're not willing to answer my questions, why would I do the same courtesy to you?
Okay. If that's how
Can you answer that? Do
It
you
is a-
acknowledge you didn't answer my question and now you're
it
asking me
is a
something?
complete non sequitur, and
What does non sequitur mean?
I don't have to answer it.
What
It
does non
doesn't
sequitur mean?
it doesn't relate, Omni.
How does it not relate?
It you are here. I'm going to go back. I'm going to keep this.
No, just
real
tell me
nice.
how it doesn't relate.
I'm
Please.
going to go back and I'm going to be real nice to your 3 points. You wanted to prove the surface of the Earth. You want a general idea of physics or the universe, and you want a model of the Earth and the solar system.
I wanted
and
those
you
from you.
and you have a piece of paper that you're trying to prove your hand or walking 3 miles. My friend, if you want to play that game, go ahead. Can you show me 8 inches per mile squared on your
It
planet or
seems
your globe?
with you calling it a non sequitur, I'll just explain to you how I would tie it back in if you actually did answer it. By answering the question, by answering the question of if this represented 3 miles after me drawing this would then prove that I can represent a physical plane without necessarily having a physical plane in front of me. You can use something in a smaller scale to represent something at a much larger scale and it'd still be 100% accurate. In that instance, we have things such as maps, which represent a physical thing at the size that it is using measurements that we dilute down so we can have displayed on a smaller piece of paper, such as maps. And using that map, we would then, after establishing its possibility, we can then get the circumference of the Earth by demonstrating the distance between the ocean, the continents, and getting it all the way around. Having the circumference, we can then get the radius. After you get the radius, you can then find out the surface area of the Earth. And after the surface area, we can then get a genuine understanding of what we believe the density of the Earth to be and how gravity affects others individuals around it. Now, if you would have taken the time to actually answer it in good faith to tell me that, yes, models can represent physical things to 100% certainty, then I would have been able to bring that to you. However, you were not able to do such a small thing. You were able to say it was a non sequitur without even understanding the point of me. What did I just explain? As I did just explain everything to you. What did I just explain that was a non sequitur? What did not make sense connected? Just tell me. Point out the things I just said. Don't bring up anything else. Just the things I said.
Are you one? I'm not going to be bullied, okay?
I'm not trying to bully you. I'm just asking you to represent it to my position.
I have a question for you. I know you got to go. So on 3 miles, when you walk 3 miles on your ball of 3,959 mile radius, how much is there hidden curve on your ball if you walk 3 miles from where you start until you end? How much of the Earth should be curving? What is the amount of Earth curvature that is hidden on 3 miles?
Can you explain to me the non sequitur that was used in my statements without referencing anything else that didn't agree with it?
I'm gonna help you. 8 inches per mile.
Well, no, so Jim, I need you to know something. When you try to act as if everything I say doesn't matter and you ignore it completely, I'm not going to give you the same courtesy. No, because keep in mind, when you say no, I gave you a 1-to-1 to 1-to-1 to 1. I brought you from point A to point C, only using the alphabet in between, and then you're telling me that no, A does not actually equal the end of the alphabet. It's not equal Z. There is no way to get from A to Z in a making sense matter. And then I tell you how it is, you tell me that's wrong, and when I asked you to tell me how, you say, let me ask you a question. Do you see how this might not be a good faith representation of my argument or a way to address it?
In the last 55 minutes, do you think you've done a good job of proving?
I think I've done an amazing job, actually, Jim. Thank you for asking.
A good job.
I believe I've shown that you will not actually address any of the points I make. Instead, you will bring up things that aren't necessarily even a part of my point in an attempt to kind of circumvent answering the question, if that makes sense.
Okay. Hey, can you tell me? Can you tell me what the drop rate, or not the drop rate, but the amount of hidden Earth curve there is on 3 miles when you walk on your ball?
I'm sure you have an answer for us.
72 inches. And if you go 10 miles, it's 66.67 feet. If you go 20 miles, it's 266.67 feet.
Let me just stop you real quick, because you're going to get to stay and you're going to tell everybody this stuff anyway.
Okay, good.
And we do have one question come in for you. So I'd like to just ask it if you don't mind, and then if
Yeah,
you
sure,
want
go
to
ahead.
say a quick closing before you run, we'll let you do that, and then Jim, you can stay and talk to the rest of the group.
Hey, Omni, thanks for showing
Yeah.
up today. Appreciate it.
Yeah, no, of course. Thanks for the conversation.
So we have a question for Omni from Rebel Babylon, Rebel Avalon, Rebel Babylon. Sorry, Rebel. We have a question from Rebel. Omni, according to hydrostatics and Pascal's principle, bodies of water always need a container and lay flat at the surface. If the surface of Earth is majority water, then how could it be a globe with curving water without a container?
Yeah, well, see, the answer to that is that there is a container, and we can observe it as we breathe our air out. When we look up at Saturn and we see what we call an atmosphere, we look at something with an atmosphere that indicates a capturing of something. Because the way things work are the denser it is, the more it's going to be attracted to a more dense object. So as Earth has a density of, say, we can just use simple quantifiers, 100, we can say land has, that's 100. We can say humans have a density of, I don't know, 10 or something. Water has a density of 5, air has a density of 2, and then space has a density of 0. Meaning that, or maybe not necessarily 0, but like nil, close to 0. When we look at our other types of things in the air, hydrogen, oxygen, methane, all these different types of gases, CO2, we can see that these things have a density. Even if they're minute, they're still a density, meaning they're attracted to the closest mass, or the closest biggest mass. And that biggest mass is going to be the Earth, and it's going to be attracted toward it. So when you have this kind of shifting sphere, you're going to have a container. When that container exists, you're going to have air in between and then water. And when that water exists, it's going to be, hey, right now nothing above me is as dense, so I'm going to be drawn down. And because there's nothing around me, and because our molecular cells make, or our molecular makeup makes it so that we can form to whatever thing we're residing in, we're going to be consistently drawn down. And if it's gone over a big enough plane, 510 million square kilometers, you're gonna have a flat-ish looking sea. And as that sea's getting dragged down, the only things above it are gonna be things that are less dense. That's why we sink when we go in, but air, if you like have little bubbles at the bottom, they'll go up.
Okay, do you have time for one more?
Yeah, sure.
Okay, so one more from Rebel. Omni, if the North and South Pole both get the same amount of sunlight throughout the year, then why does the Arctic Circle have a lot more variety of flora and fauna compared to the Antarctica? Shouldn't it be the same? And then some emojis and a thinking.
It's a good question. I don't know. I don't know much about biology, or a little bit. When it comes to biology, I know about like animal biology and how they grow in different areas. It might just be like the way certain like amoebas like grew up. Like when you talk about single cell organisms, when like evolution happened, it could just have been this actual people that grow up there, the luck of the draw, right? You'll have a relatively similar situation, but if it's more fauna, I would say maybe it gets more sunlight, right? If you look at the actual rotation of the Earth, when you look at the axis, when you use what was it, Foucaultian pendulum? It shows the axis, like maybe there is like a slight favoring toward one pole in consideration to the other. I just don't know. That's just my theoretical asks, I guess.
Okay, and then we did have one last one come in from Nurgle Cultist.
Mm.
What do you think about the flat Earth theory being intentionally spread by the CIA to draw attention away from the hollow Earth theory? That is not for anyone, but Omni, I'll give it to you, and then maybe Jim, you can answer that too, and then we'll just let the audience talk to you, Jim, and Omni, you can.
Yeah, I would say, wow, that sounds super interesting, and I can't wait to read up on it. And thanks for the talk. I do have to go. My girlfriend is very mad at me, but great talk. Thanks
Thank
again,
you, Omni.
Jim.
Take
Hope to
care.
see you around. Adios.
Take care.
Okay, Omni's gone. Thanks, Omni, and thank you, Jim. So I guess there are some questions in here. Instead of just me trying to read everything off, Jim, you can probably see the chat and read them. Maybe we can, if people want to come up, if people want to raise their hand and talk to Jim for a few minutes. What do you think about that, Jim? If people want to raise their hand, ask
Oh,
you a question or two, or would
yeah,
you like
that
to read the questions, or how would you like to?
it is where's the question, sir? Is it in challenge debate or after show chat or VC chat room?
They're in challenge debate. Like if you click the thing, they're all tagged to me, so it might be kind of hard for you to read. I can read them to you as well, because they're
I'm
highlighted for me. So
okay. I don't want to lose you. I tell you what, I will, if it's okay, I'll practice with this on Saturday. Is that okay?
sure.
I don't want to click on something and lose you because I probably will.
Yeah,
Oh,
that's fine. That's fine. So
thank
yeah,
you.
so
Thank you.
I can just read them off then.
Thanks.
Yeah,
And if
so
anybody wants to come, if anybody wants to come up, they're welcome to. Sure.
yeah, so I think that might just be a little bit more fun since you have some more time and practice just like chatting with people. We can have people raise their hand if they want to come up and ask you a question and stuff. Uh, I don't know. Yeah. So does anyone want to come up? Let's just see that. Anybody wants to come up, go ahead and raise your hand. And if nobody does that, I'll just read off the questions and then we can wrap this up and maybe jump to one of the other VC, the regular VCs or whatever.
Mhm.
Hello there.
Hi, how are you?
Hi. Very well, thank you. How about you?
You sound Australian or British?
Both, either, neither, whatever.
Okay. How you doing?
Pretty good. It has been fun. I hope I sound good enough. I turned out a good microphone for this.
Oh, you do. You come across great.
That'll be fair enough then. I don't have a background for everybody to look at though, so that's going to be my fault. So, quickly, just I don't actually know if this has been asked before or not. I kind of missed a little bit of the conversation because Darth Dawkins happened downstairs, so I kind of had to
Mhm.
look. But what is down?
What is down now in the fairy tale globe world or in the stationary topographical plane world?
Oh, in general. When you say down, what does that mean?
Down means basically where things will go if you drop them. They will go down unless the thing you drop is will go up because of helium or something that because it's lighter than air. But generally things do drop, but some things do go up as well. Um, there is I didn't get a chance with Omni. I kind of went through Cavendish quickly, but there is a simple kinematic equation that deals with. We don't have to worry about radius and mass and all that stuff. We can actually just take height of an object above the ground. Doesn't matter how high it is. The time that it takes to fall to the ground. We can take the initial velocity, which is generally zero, and we can determine the constant acceleration downward through a. Excuse me, and we can deduct those things down all the way down to, and I'll skip all the equations that take it down there, but you can actually get down to, without even trying, without even having to get really, really, really particular, just using some sort of a precision watch or stopwatch, you can get to acceleration equaling 10 meters per second squared. The agreed upon average is 9.81 meters per second squared. So you can come within 2% just using height, time, velocity, and acceleration, and you don't have to have a scientist tell you or make up mass or make up radius. Anybody could do it. You don't have to have a scientist do it. You and I could go out somewhere, drop a tennis ball from a certain height, measure the height, time, velocity, and we could come up with 10 meters per second squared, and you and I would never even had to broke a sweat. So this whole gravity thing, just like the ball, just like the globe, is made up for whatever reasons. I have my opinions why, but what is down is what falls if it is heavier than air.
Okay, so things that are heavier than air. So this is very much about density and mass in that sense.
It can be electrostatics, it can be density, and it can be buoyancy. Density is pretty easy to talk about, but you have electrostatics. The general term on the stationary topographical side, flat Earth side, is that electrostatics, explains much, and density and buoyancy fill in the rest. That's kind of what the short answer is. It can go deeper than that if you want to, But that's kind of the short answer.
That's fair enough. The question I kind of started from were from a different direction. Why do things that fall go down instead of sideways, for example?
Oh, it's quite simple. Electrostatics, the things there is, you have, hopefully you agree, there is a downward bias on the earth. Downward bias means that when you drop something and it is heavier than air, it will go down and not that way. And so if we come to understand there's a downward bias on the earth, then things will go down unless it's a balloon full of helium and it's lighter than air, and it will go up.
That would be a problem, though. Why doesn't helium want to go left?
Maybe it will if the wind blows it, but I don't know that answer. Why helium doesn't want to go left or right? It just wants to go up. So that is probably, to answer why helium doesn't go left or right. It just doesn't. But that's not a scientific answer.
Well, somebody better than me would probably note how the scientific answer would be gravity. But on the other side of that, since I don't really care about that side, I would just say, if there is no answer for that, why do we accept that there is none? How do we explain things falling in a specific direction instead of any other? Why do denser things go down instead of sideways or up?
Well,
Or
that's a
laterally,
great,
or in any inclination other than that one.
because there's a downward bias on the earth of things that go down and not
What
sideways.
is a downward bias?
Downward bias means when you drop something, it's biased to go down.
Why?
How things are.
I do not have a way of considering that an answer.
That's the answer I have now. Why things go sideways. There are different factors that do that. It might be the wind. It might be magnetism. If you happen to rub a balloon on something and you put it on the wall, it will stay there until the electrostatic effect causes it to come to the ground. But the balloon, when it loses its static effect to the wall, doesn't come this way. It goes to the ground because there's a downward bias.
So we have no way of accounting for the downward bias and what it actually is or is caused by.
It's a downward bias. Is there something that you would say naturally goes sideways?
No, that is
Okay.
why I would consider that to be a problem. If all things point to one direction when they are considered from us to be following, there
Mhm.
would be a reason. And if we cannot point to what it is, the mainstream round Earth model would have an explanation that seems to fit the fact.
What does the globe have that explains why things fall to the ground?
A larger mass attracting smaller masses.
And that was Cavendish, and I explained electrostatics. Maybe you didn't hear it because I think you said you came in a little bit later.
No, I did get to hear that side.
Yeah, I went through Cavendish and I went through the alternative to Cavendish, which mass attracts mass. Now, if we are a big believer that we live on a spinning, watery, curvy, bendy ball in the vacuum of outer space, and we're going around at 1,037 miles per hour at the equator, and we're going around the sun, and we're going around the Milky Way, and we're going around an ever-expanding universe. If somebody wants to go with that, I can't stop them. I can give, and a number of people that can give the alternative to it, but gravity cannot be proven. Is gravity a wave? Is it a wave form? Is it a particle? Is it quantum mechanics? Is it general relativity, which it isn't because it's the bending and warping of space-time. And we know from the Royal Society in November 6th of 1919, they basically told the media press that the bending and warping of space-time is now the official reason for gravity, and they threw Newton to the curb, and they threw mass attracts mass to the curb. Cavendish comes back. I don't remember the exact year, early 1900s, and he did a little experiment where two little things attracted toward each other, and everybody went, "Oh, we have mass attracts mass. Good job." but that was the only explanation we were given. So I gave the alternative explanation. You can accept it or you can't, and it's okay.
Okay,
That
I
is
think that
fair
was a
enough for
good.
what amounts. Sorry.
Yeah, I think that was a good response. Does anyone else want to come up and ask a question? Because otherwise, I'll just read through the other questions because we do have other questions. So I want to read
Yeah,
through those.
and thank you for your question.
And thank you for being here. I'll be happy to step down if somebody else does want to come up here.
All right, so I'm going to go ahead and read through some of the questions that we got earlier. So we got a question from Who Done It. The question was for you, Jim, from the beginning of the show. Jim, when the time comes, if models don't exist, how do we predict weather with reasonable accuracy?
If you want to go through the Soros cycle, which is basically a prediction, post-diction, you can go through predictions and post-dictions, but you don't have to go through a model. You can go through predictions, you can go through post-dictions. The Soros cycle is one great idea that we know kind of what's going to happen with lunar and solar eclipses and things of that nature. Don't quote me on this. I think it's a 15, 19 year cycle. And so, we can make predictions based on what's happened in the past, but I reject the fact of a model because if I can give you today, concave seems to be a real big thing, and people are throwing out models left and right as far as what they think concave is. It doesn't make it factual. The globe doesn't make it factual. You can even say a model of the flat Earth stationary topographical plane doesn't make it factual. What we do and what I specifically believe in, why I became somebody like 16, 17 months ago that doesn't believe we live on something like this, is that I found out about health and viruses, and I went, okay. And then I looked at something else, and it's like I looked at the shape of the Earth, and it's like I don't experience 8 inches per mile squared. I don't experience motion of the Earth around the sun. I don't experience bendy light in the vacuum of air. I don't experience large bodies of water at rest curving around the ball. So there's just certain things that they came to me and said, "Hey, we don't live on a spinning, watery, curvy, bendy ball, and we've been lied to since age 5." And and again, 85, 86, 87%, whatever you want to believe we live on a spinning, watery, curvy, bendy ball. They do so mainly because they were told they did. They were told and taught, but they've never experienced that ball.
Okay, thanks for that answer, Jim. Bouncing around a little bit here. So going back to weight and gravity, I guess. Anathema asks a follow-up to the down question.
Yeah.
Is a compound question. What is weight then, and what makes something weigh anything? And hold on, this is from a different room. And why do objects drop with a measurable 9.8 meters per second square?
9.81 meters per second squared is an agreed upon average. There are certain parts of the world that it drops at 9.82, 9.83, 9.77, 9.78. It's an agreed upon average. It's what things do. That's what our observations and science tell us happen. So why things drop at a 9.81 meters per second squared? That is what we observe. That's what we experience. And it's not done, it's just not made up somewhere. We can actually observe it. We can experience it, and we can experiment with it. It's agreed upon average in 9.81 meters per second squared.
Thanks for that answer. Okay. Just going back to an earlier question from Be Good. I don't actually know what it's referencing because it was earlier, but Be Good asks, did you know your quote was a severe quote mining? I'm not sure which quote that was.
Yeah, quote mining is a really, really great, I don't know, when you oppose, maybe you don't oppose, maybe this person doesn't oppose the stationary topographical plane, but you can often tell somebody that they're quote mining just because you don't agree with their comment. Now, I will say this. If the person does want to, come up and say, why I, quote mine. I know a lot of people say that Einstein was quote mined, and because they leave off the part that says, but Einstein said that the Earth still moved around the sun. Of course, he had to say that because he was Einstein. But Einstein said basically there's no proof through an experiment or observation that we're actually moving around the sun, but we're moving around the sun anyway. So quote mining is an interesting thing. I would like to know, what particular item was quote mined, and then I'll definitely look it up. Absolutely.
Yeah, maybe it'd be good if you can mention in the chat if you remember which one it was in reference to. I didn't mark it down when you tagged it, so sorry about that, Jim. Then Whodunit asks, Jim, if I recall, you stated that there's only one Lorentz transformation formula. Are you sure about this fact?
The Lorentz transform is used in various forms to be. We can at some time in the future, we can talk about Lorentz transform. It's very fascinating that you're looking at. There was a question between Michelson and Morley in 1887 when they saw that through their interferometer experiment that instead of going 30 kilometers per second around the sun, they measured more like 8 kilometers per second. And through, it was 1930, the last one being JOOSE, Joose, that they found that it was 1/6 to 1/10 of what the 30 kilometers per second showed. So that's 3 kilometers to 5 kilometers per second. So the interesting thing is that the globe people, the globe earthers, will use the Lorentz transformation, which the most basic one that I know of. If there are more, then I stand corrected. The most basic one that I know of is 1 to the square root of 1 minus v squared divided by c squared, velocity squared divided by speed of light squared. So I know that's used. Now, you can change that Lorentz transform equation. You can change it from a multiplier to a divider, from a divider to a multiplier, and you can use it for time dilation. You can use it for mass increase. It's something that we can talk about more, but yes, you can change the Lorentz transform to get to the coordinate system that you prefer, which is the Earth going around the sun. Time dilation we didn't get into. Maybe some other time we can talk about time dilation in pound Repka, pound Snyder, and Halfley Keating. Maybe we can talk about that. We can talk about the atomic clocks. One in Boulder, Colorado, 5,400 feet. One in London, that's 0 feet sea level, and about how difference they show as far as the atomic clock. We can get into that. There's a lot of things in an hour we didn't get a chance to get into.
Yeah, so I think Whodunit says that was a yes or no question. So maybe he wants to challenge you to another debate sometime, Jim. I know you're always itching to debate more people. So Whodunit,
Yeah.
I think you threw down the gauntlet, and you're going to have to go to the debate room and challenge Jim. So there you go.
It's all cool. It's all good. No problem.
So we've got a question from Gek about the mathematical models. He asks, we can use mathematical models to represent reality, and we do. I can have 2 apples, and if I buy 2 more apples, I would then have 4 apples. Therefore, does 2 plus 2 equal 4 not accurately model a transaction of acquiring 2 more apples when I already have 2 in reality?
That's a great question. I can observe and experience and see that. I can actually see that. I can see it. Now, if I can't see it and I have to rely on scientists to tell me about special relativity, about general relativity, about the bending and warping of space-time, about actually the reference frame is just fine. Because the reference frame is basically says where we are when we see something is based on light. but that is not, you know, when you're talking about 2 + 2 = 4, you deal with apples. That's a whole lot different than dealing with the Schwarzschild metric. That is so much different than dealing with equations that deal with quantum mechanics. That is so much different than dealing with Maxwell's equations. That is so different. I appreciate the question. It's a little bit of a gotcha question, but that's okay.
Okay, thanks, Jim. Be Good asks a question about science epistemology. Do you understand that gravity is a fact, like things falling, and science does not prove things?
Is the question inferring that gravity is a fact?
I think he's just flat out stating it. And
Yeah,
then
gravity is not a
asking-
fact. A gravity is not a fact. A gravity 9.81 meters per second squared, mass attracts mass falling to the ground, is an agreed upon average. If you want to talk about gravity with the general relativity, which is Einstein, which is the bending warping of space time, and you want to deal with two pictures from November 6, 1919, that supposedly proved the bending and warping of space time around the sun. So instead of the star being apparent or being actual, or actual being apparent, if that proved the bending and warping of space time, great. But gravity is not a fact. The bending and warping of space time, at best, is a model. At best, it's a model that somebody uses to say, hey, bending and warping of space time is correct because we have a model. But if somebody wants to come out and say that bending and warping of space time is physical, then I want them to prove it to me. I want them to maybe talk to me face to face in a debate if they want to, and we will talk about gravity being real or a fact or a law or something like that.
Okay, Be Good, there you go. That's the answer. And Jim is willing to have a debate specifically about the fact of gravity if you'd like to do it, or if anybody else would like to have that debate. Okay, another question from Whodunit. Where do I put the observer height in 8 inches per mile square equation?
That is a great question. You know, the first three, if you Google Earth Curve Calculator, the first three things, at least last time I looked, first three things had the Earth Curve Calculator. The very first one, if I remember right, was you have four things. You have the distance to target, you have the height of the observation, you have the hidden height, and then you have the geometric or physical horizon. Those are the four things that are on the Earth Curve Calculator. So, for example, if you are, and you know, and I've been there, and I will continue to go there. If you are 62 miles across Lake Michigan in St. Joseph, Michigan, 62 miles away, at 6 feet observation height, kind of what I am, or maybe what a tripod with a camera would be, you are, if I remember right, you are 2,321 feet worth of hidden curve. 2321. I think that what it is. If you're at 30 feet observation height, which might be a hotel that they have on the beach, you're at 2,038 feet observation height. So yes, observation height is part of the four items that go into distance to target, observation height, geometric or physical horizon, and your hidden curve. Those are the four parts of your Earth Curve Calculator. I hope that answered the question.
Oh, thank you. Okay, next question, also from Whodunit. So what's the equation for buoyancy?
Don't have it right here on top. I know buoyancy has gravity inside of the equation for buoyancy, but all you have to do is replace the G with A, and you're just fine.
Okay, and then this is going back to the weather question. Whodunit again, following up about the Soros cycle. And he asks, we are able to accurately predict weather. How do we do this without a model?
The solar cycle is a post-diction, prediction, whatever you want to call it. So you don't need a model. to predict eclipses because they have already been predicted or post-dicted. You don't have to have a model. You don't have to have a model because we have things that we have observed in the past. We have the solar cycle, and so we don't need a model. If people, and it's fine because freedom of speech. If people want to keep talking about a model, then that's fine. But I personally do not live on a model. Concave has a model. I don't live on a concave Earth. And as I've showed you before, I have a model of Santa Claus. I have a model of the Easter Bunny. When people talk about models, I smile. I say, we don't live on a model. If you want to live on a model and say a model predicts things, great. Predictions predict things. Postdictions do the same thing, but a model does not. I think a model. I don't buy this, guys. I don't buy this, ladies and gentlemen. I don't buy this. This is generally a model. I don't buy this at all. I don't buy 23.4 degrees, tilted, wobbling, spinning at 1,037 miles per hour at the equator, less as you go up, and around the sun, and around the Milky Way, and around the ever-expanding universe, which Hubble talked about in 1929 when he talked about redshift and blue shift, and he saw more redshift as he looked out. Therefore, it was ever-expanding. And that's how we came up. Hubble actually gave us the ever-expanding universe.
Cool. Thanks, Jim. I think we're actually almost done. There's one last question on this board from Shadow Company. It's back to gravity again. If gravity isn't a fact, why can't we demonstrate gravity by ourselves? What goes up must come down. I think you already answered this, but if you want to just give it one more.
Sure. I just come back. For 97% of my life, I thought I lived on a globe or a ball. And, we were taught certain things, maybe from the crib when we looked up and we saw, a cartoon. We saw something Mom and Dad bought us that was the sun and the moon and Saturn had some rings. And then maybe when we looked through, when our folks read to us when we were 2 or 3, they were flipping through a page, and we saw a globe on the page. Or when we went into kindergarten, we saw a globe by a teacher's desk. And we were also taught from our earliest memories that things fall to the ground and it's gravity. Okay, it's gravity. Something fell on Newton's head, but Newton never read about it. He never wrote about it. So were they sitting around the water cooler in 1690 with some of Newton's friends, and Newton said, "Hey, by the way, an apple fell on my head 24 years ago. Will somebody please write about it so we know about it?" Because Newton never wrote about the apple falling on his head in 1666. And so gravity is at best a theory, but nobody has ever proven gravity. It is Newton's mass attracts mass. They threw Newton out November 7th, 1919. They replaced it with the bane and warping of space-time. And for some reason, people want to combine the bane and warping of space-time with mass attracts mass, and we have this great little family going on. There's this big push right now, as far as we've gotten to string theory in physics. There's this big push to unify all of physics into one theory. It will never happen. String theory is never used because you don't see it anywhere. You don't see gravity. We were told from age 5 or sooner that when you drop something, it falls to the ground, and we were never given an opportunity to learn about anything else.
Okay, so one last question came in. Why do structural designers take both Earth curve and gravity into their calculations? And that was from Inquisitor, and that's
Great
the last
question.
we have.
Great question. The spherical excess, the plane versus geodetic surveying is a very interesting topic. No engineering, no architecture, and no blueprints have ever factored in curvature of the Earth at 8 inches per mile squared. Now, if that wants to be discussed, that's just fine. But no engineering, no architecture, and no blueprints have ever factored in 8 inches per mile squared. And we can go, through examples. We can talk about geodetic surveying versus plane surveying. We can talk about spherical excess. We can talk about all those things. I don't have a problem if somebody wants to, get in touch with me and we have a debate about certain things. I don't have a problem with it. But when somebody says that it's been built into whatever they built, that is wrong. That is false. And I want to see it where they did.
Okay, Jim. The questions actually just keep on coming. I did get one more in, and then I think we'll ask if anybody else wants to come up and chat. And if any time you want to go or you're getting tired, just let me know. Obviously, it's all up
I
to
got
you at
water.
this point. I
We're
think a
good.
lot of people are having fun. We still have a pretty big audience. So um, we got a question from Nathama asks, a model of an Easter bunny makes no predictions of natural phenomena. We can, however, make predictions that are 100% accurate using the globe model, but why is it that we can't make any flat earth, sorry, why is it that we can do that, and why can't any flat earth model make any accurate prediction?
How many times, my friend, did the word model in that question? Was it 3 times or 4 times was model in that question?
3 times at least.
We don't live on a model. You can't prove we live on a model. We experience, we observe, and we see our world. That's what we see. I don't see a globe. I can't measure a globe. I don't have 8 inches per mile squared. I can't see a motion of the earth around the sun. I read something off at the very beginning, and I don't know. Forgive me for those that, this is what I read off at the very beginning. And this is why I reject a globe model. We think it's a ball, though it measures flat. We think the earth spins, though we don't feel it. We think the earth moves around the sun, though we can't measure it. We think water curves around the ball, though we can't see it. We think light curves in the medium of air, though we can't prove it. We think gravity exists, though we can't explain it. We think there's a universe, though we can't verify 95% of it, which is dark matter. And so when somebody keeps talking about a model, it's okay. You talk about your model, but I experience, I observe, and I see a stationary topographical plane. And the stationary part comes about with Michelson Morley in 1887, goes through all the experiments. I can read off the people that did the experiments, especially Dayton Miller did many, many experiments. Nobody has ever proven motion of the earth around the sun, not one time. So talk about your model, it's okay.
Anathema asked a follow-up question, saying his question was more about why can we make predictions, though, about the natural phenomena based on our understanding of the globe and the globe models, but we still can't make those predictions on any flat Earth.
I think the thing that I've seen talking to a gentleman from an Ivy League school, and also talking who is a globe earther, and somebody who thinks like I do, that 99% of what happens on a globe model can happen on a flat Earth model until you go to outer space. 99% that is on the terrestrial or on the Earth on either model, and again, I'm just using model because the question had model, works on either model. Now that's a question that, that's something you can discuss later on, but everything basically works on a stationary topographical plane as well as it does on a globe, planet, sphere, oscillating spheroid, whatever you want to call it. The difference is when you go to outer space.
Okay, thanks, Jim. Anathema still says he didn't use those words, but I guess that's Jim's answer, Anathema. So maybe if you want to schedule a debate with Inquisitor asked Jim, can you define model? What is a model?
I think I kind of joked about it before. I can define a model as a guy or a girl walking down a runway, either showing off their body or showing off whatever they're wearing. But if you want to look up the dictionary term of model, go ahead. It's not a problem. Is a model a representation of something? I could look it up right now. I have my phone and I can look up, I could Google model definition and we'll see what it says. It'll take me 15 seconds. Model definition. Model definition, what I see, looking it up on Google, a model is a three-dimensional representation of a person or thing or of a proposed structure, typically on the smaller scale than the original.
Yeah,
there you go.
Inquisitor's adding specificity. He's asking like specifically a scientific model, not just any model.
If you want a scientific model to prove your ball, your globe, your sphere, your planet, your oscillating spheroid, your oblate spheroid, you're talking to the wrong person.
Okay. And then Be Good asks, how much value do you give to unsupported claims? Do you have any flat Earth scientific paper?
That is a great one for a debate because I never got into stationary topographical plane evidence. I have a bunch of it, but yes, there is no empirical and physical evidence that we live on a spinning space ball in the vacuum of outer space. There is zero, but we observe and we experience and we see a stationary topographical plane, and there are many places that can prove that. Maybe that's. I have a lot of things that I didn't get through, and one of them is measurements and observations.
So Be Good says in the chat that they'll debate you on that, specifically on that topic, evidence of the flat plane. So that's great. So they'll message you after to set that up, so you guys can coordinate.
Sure. If you'll have me again, no problem.
Oh yeah, absolutely. So does anybody want to raise their hand and come up and chat or ask questions or anything else? All right, I don't see any hands coming up.
Well,
so I think
I seem to still be here, by the way.
I can throw you down if you want.
Well, I mean,
All right then. Anybody want to raise their hand? All right, well, thank you, Jim, very much for coming. If you want to say any last remarks, and then we'll thank our audience and we can close down the stage. And if anybody wants to run to the any of the VCs, people can have a much more open chat, just talk over each other or shout at each other, whatever you'd like.
Hey, thanks for having me, and thanks for everybody who watched and asked questions. Your modern day debate is going to have me Discord 2 times on Saturday, and so thank you for that as well. And it's been fun. I appreciate the opportunity to talk about our stationary topographical plane. Thanks.
All right, thanks everybody. We're just going to go to the VC now. If people want to hang out, Jim, you're obviously welcome to hang out there and chat. People are just jumping over there. Thanks again, and we'll see you all later.